Hello, welcome back. Hope everybody enjoyed that quiz. Let's see how you did. I am not optimistic on this one. It was a hard one, especially to do in 10 minutes, right? Okay, so about 50%. Tough one. Most people, looks like 50% on the first one, and then a little bit lower on the last two. Uh, well, someone asked, how does a hole play into it? It's It's a folk song. Don't read into it too much, okay? There's a hole in my bucket. Yeah, a pipe is technically a hole. Just on both ends, isn't it? Okay, so I didn't actually copy the code for this one into Eclipse, so I'm just going to do it in the quiz itself. We'll just go over it in the quiz itself, so hopefully you can see it. I guess I'll zoom in a tad. A little grainy, better than nothing. Yeah, good enough. All right. So we've got our driver. We made 3 buckets. That's all you really needed to note there at the beginning. And then we set the destinations. I cut this off a little, actually, because we'll note what setting destination means first. So let's go and find it. Looks like it comes from the interface pipe. I see it there. And then the bucket implements it like this. It just sets destinations to some array that it has as a field. Well, that seems pretty straightforward. Okay, so alpha has beta and gamma as destinations. Beta just has gamma, and gamma has alpha and beta. Then I set alpha's water to 10. Well, let's see, what is water? Where does that come from? That comes from water container, and it's just an integer, and it doesn't look like there's anything else in water container, so that's pretty straightforward. A water container is something that has water. And then I did alpha.flow twice, then beta.flow, and then gamma.flow. So now I need to figure out what flow does and figure out how much water is left in each bucket. So we started with 10 waters, and then alpha flows twice, beta flows once, gamma flows once. So let's deal with alphas first. So alpha's got 10 water, and it flows twice. So for all the water containers in its destinations, if it still has any water left in it, so if the water is greater than 0, then the other water container, W, the one that it's connected to, so the destination, that one gains 1 water, and this container loses a water. So you got alpha's connected to beta and gamma. That means if it flows twice, then alpha loses 2 water each time it flows. So alpha's going to have 6 water left at the end of those 2 flows. Beta's going to have 2, gamma's going to have 2. Okay, so again, alpha will lose 1 water for every 1 water that it gives to the other containers. It's going to loop through all of its attached containers. I didn't pull any bamboozles on you, and they're never going to be insufficient to give water to all of their destinations. So I have this check, but it actually never does anything because in this example, they always have enough water to complete the loop. But it's going to give 1 water to each of its destinations and then lose 1 water for each one it gives. So you're going to end up with 6 on alpha, 2 on beta, 2 on gamma. Then beta flows, but beta only has 1 destination, and that's gamma. So beta had 2, gamma had 2. Now beta has beta loses 1, so beta has 1, and gamma gains 1, so gamma has 3. Okay, which brings us to gamma flowing. Okay, so gamma flows. Let's write this down easier after that, so otherwise I feel like I'm losing. Alright, so alpha has 10 after 1 flow. We'll call it after alpha flow, and I'm just going to do it 2x, but I don't want to do it twice. So alpha has 6, beta has 2, gamma has 2, Then after beta flow, beta has, well, I'll say alpha still. Alpha still has 6, beta has 1, and gamma has 3. Alright, so after gamma flows, yeah, someone asked, would this be an error because the beta and gamma buckets never got their water set to 0? I took advantage of kind of, I guess you can call it a bug, that it defaults integers that aren't initialized to 0. I don't think it always did that. I think in previous versions of Java demanded that initialization. So it's a little bit interesting that that works, but no, actually it does run because water gets initialized to 0 on account of having that default initialization. If water was some other kind of object, something that was nullable, then this would have a problem. So that's our state we're in after the last flow, and then gamma will flow. That, of course, is going to give... Oh no, I only have 5 minutes left on this quiz. After gamma flows, alpha is going to gain 1 because gamma is connected back to both alpha and beta. So now alpha will have 7, beta will have 2 again, and gamma will have 2 again. I think that's the answer. Let's see. 7, 2, 2. Oh, 1 left in gamma. What did I do wrong? Gamma isn't 2. Did I miss a flow here somewhere? Or did I actually just put the answer wrong in the key? That could be a problem too. Gamma flows into... Oh, you're right. I unlogicked it on that last step. So at the previous step there after the beta flow, and this is why it's good to write them down, because otherwise I would have to go back through the whole thing. So on the previous step after the beta flow, alpha had 6, beta had 1, and gamma had 3, and then, as somebody noted, gamma flows into 2 buckets. So gamma's going to have 1 left. Right. That's a fun question, isn't it? So, not particularly related to objects, but you did have to track the different interfaces and such in order to get that down. All right, so moving on to today's exercise. Any questions, actually, before I move on the bucket problem? You could ask, how come, there's like a series of pipes, one to the other. Like, how come alpha can connect to gamma and gamma can connect back to alpha? Well, it's not uncommon for an object to connect to another object, and then that one to connect back. In fact, that's exactly what we had to do in our homework, where we had to connect the 2 panels together. So it's not really an uncommon thing. I posted my scratch sheet there for you to consider. Okay. Yeah, moving on then, if there's no questions. Let me ask one little riddle before we continue. What would happen if I had set, let's say, alpha's destination to alpha? What would happen if I set its destination to itself? Would there be any problem? I'll show you the float method so you can think about it. What would happen if alpha was set to its own destination? Take a poll, I guess. Not something that usually comes up, but let's say that you were doing a problem like the homework with the 2 panels, and you had decided to link the brother panel to itself on accident. So in that situation, it would have caused some issues, but in this situation, as most people who have voted said it's not a problem because all that would happen would be it would gain a water and then lose it, and take you right back to where you started. So that's actually a bad thing because in some instances we can accidentally make these little loops where we link objects back to themselves when we weren't supposed to, and they can be pretty tough to notice until the problem pops up later. So this can be a dangerous thing that sometimes you can link it back to itself and not notice until quite a bit later. Alright, so today we're going to finish up with exceptions. If you don't really see the point of exceptions yet, don't worry about it. We will probably see that a little bit over the course of this semester, but you're going to see the point of it more when you get to 328, which I should mention as well is now called 229, and if you have plans to be a computer science major, you should sign up for 229 in fall, I think. So coming up next. It'll probably be relatively packed, so get on that if you haven't. Alright, so in the last time when we were looking at exceptions, I just used this word exception in each catch. Now, what if you have a situation where you care about a particular exception? So exception is actually the parent class of all exceptions, and it's the catch-all for any kind of exception that you may have. But you could actually designate individual exceptions too. So I'm going to call this multiple exceptions example, be a method. And we're going to try to do all three. We're going to try to do going out of bounds on a substring, or going out of bounds on an array, a null pointer on a substring, and dividing by 0 all at once. Let's try to get them all together. So string s, try, let's do a random number. So that we don't know which error we're going to get. It'll be a mystery. S equals cake. But in the other circumstance, we forgot to set s to anything, so s stays null. Alright, so we're going to try to do s.substring, or something that involves having a string that's not null, and of course this will fail if we don't have s set up, which is what would happen in most or half the cases if random doesn't roll correctly for us. So string small equals, and this will fails if rand less than 0.5 and string isn't set. Okay, for divide by 0, I'll try to do small dot char at 0 dot, I don't know, let's just make a couple integers. Int a equals 3, b equals 4, and again I'll do if rand, I'll do it up here too so we don't know which exception we're going to get. So I'll have an int a and b, and let's actually show kind of that weird functionality that I used in the quiz, where b is going to be treated as a 0 if I don't set it to anything. So b will be equal to 2 if random is less than 0.5, but b will just be equal to 0 in the default condition. So we'll do int c equals a over b, and this fails if rand greater than 0.5 and b is set to 0, which is the default. And I wanted to do out of bounds as well, so let's do string char equals small dot to character array, which I'll show you here because it's actually a pretty common way of dealing with strings. We've got some need to do a lot of index operations on them. It's better to convert it to a character array than to do a bunch of calls to char@, most of the time. It's also usually a bit easier to work with when it's a character array versus having to do the string.length and char@ repeatedly if you're going to do a loop or something. So converting to a character array and back again to deal with strings is a good idea. Whoops. I said string in front. And then we're going to try to get char big equals small of 9, which doesn't exist. Oops, chars of 9, which doesn't exist. So we have 3 different problems here, and we don't know which one is going to happen. So we're either going to get a exception because of the substring, or we're going to get an exception because of divide by 0. It occurs to me now that we're going to get one of these regardless, so I'm going to have to play with the random number a bit. So let's say if it's greater than, well, let's go with less than 0.75 or less than 0.5. Sure, they don't have to have equal odds. So this one fails. String isn't set. And this one fails if B is set to 0. And now let's deal with the 3 possible exceptions that you could get here. So they don't have to be in order, but in this rare case, usually the order that your methods and stuff are placed in doesn't matter. And that's true, but you do know already that the order of your if statements matters, right? The topmost one will execute first if you have a series of if statements, and exceptions work the same way as that. So if the topmost exception that counts will execute first. The topmost exception that counts. That means if you start with this, if you start with exception E, then there can't be any more below that, because this would capture all of the possible exceptions that there are, because all exceptions have exception as their parent, right? And now it's not happy with me that I didn't initialize them. Okay. A little quirk of the try-catch block, I guess. Alright. Initialize them. Alright. I have my exception E catching all of them here, and if I print out the error, which is what print stack trace does for you, then, oh, I never called it. Let's call it at the end. Okay, then I'll get divide by 0 occasionally when I run it. Occasionally I'll get null pointer exception. Let's see if I can get the out of bounds one to go. No. Arithmetic, no. Arithmetic, no. No. Whoops. Gotta flip my signs for randomness. No, 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 no. Arithmetic, no. No, no, no. I am not getting my out of bounds. Oh. Wow. Didn't think that through. Okay, so let's just make a new character array for this, because I didn't think of the fact that if the second one fails, if the arithmetic fails, then of course it doesn't pass that check either. So I'll just do some stuff here that's obviously too short. Okay. Null pointer, null pointer, null pointer, null pointer, null pointer, null pointer. Getting very unlucky with null pointers here. I got an arithmetic there. I still haven't gotten it out of bounds. Hard to pack them all into the same method, isn't it? And yet, sometimes you do it on accident. All the time, in fact. Okay, so if random's greater than 0.75, or if random's less than 0.75, then we have this error. If random is... I'll just let them have some overlap, so we can have neither. Null pointer, other arithmetic, null pointer, null pointer, null pointer. Oh, let them have some overlap with both. Okay, I got divide by 0, divide by 0. There we go, I can get some out of bounds now. Now that they can have some overlap. So you could have neither of these. If random is smaller than 0.25 now, you have both. If random is bigger than 0.25, then you don't have the string fail. If random is greater than 0.5, then you also don't have the integer 1 fail. Anyway, now we have all three exceptions. Whenever we run this, it prints out the one that we get. And you can read all the different exceptions that there are available in the java.lang.exception library right there in the exception name. Notice that that maps to some of the ones that I've prepared for you here. You've got your null pointer exception. We've got our array index out of bounds exception. Boy, that's a long one, isn't it? And then we've got our, what is divide by 0? It is actually not divide by 0, it is arithmetic expression. And that doesn't necessarily only happen when you divide by 0. There are other ways to trigger the arithmetic exception too. So instead of doing this catch-all exception, let's do all of those individually. So I'm going to copy and paste this in because those are all a bear to type. Oof. I did the stars thing. Why did I do that? Now there's no short way to get it out. Okay. Don't do the stars thing. /star. Where am I here? Okay. Okay, so I'll have it print. There are other kinds of print besides out. If you want to get the red text that indicates that an exception or error has occurred, you can use system.error instead. So if you want to print your own custom message like that, you can. But the stack trace is preferable because it gives you all the details, and it also gives you those links to where you need to click in order to see what's going on. So it's much more useful for debugging. So if it's an exception you don't want to handle in the sense that you don't want to just fix it, then do that instead. But let's say that you did want to fix it, so you're going to be like c equals 2 no matter what here. Well, that would be another story. I'll declare c up here so we can actually do that. And for null pointer, I don't know, what do we want to do there? Let's try something different. Let's try big equals cares of 2 instead, since that actually is valid. Again, I'll move that up there so we can actually do that. And I'll move this up there. Well, I should point out why I'm doing that, actually. Yeah, so the catch block doesn't have access to the local variables that you created in the try block. That's interesting, isn't it? So you can imagine these as separate statements. Like if you made some local variable inside of an if statement, you wouldn't expect to have access to it in the next if statement. And it's the same way in the try and catch block. So you don't have access to the local variables that you created inside of the try block within the catch, which is a bit odd, isn't it? Okay, and now I have the problem that I haven't initialized my chars. So I could take the lazy route and like null it. Alright, so now when I run this, I can get different exceptions. So first there's my out of bounds. Notice that it prints my custom out of bounds message right there first, and then I have the stack trace printing out. It's occurred to me that I didn't actually print anything here, so that's not interesting. Let's print it out to system.error on both counts. Oops. So let's look at the other two cases. We get out of bounds again. There's my arithmetic expression. So I didn't do a stack trace print there, so you just see a 2 in red text for my divide by 0 when that occurs. And for the null pointer, oh, I got it, and then I just scrolled right past it. There we go. So for the null pointer, I still have it. In fact, it wasn't handled because I accidentally did this. And I did this when my chars array is still null. So this part, let's fix it by doing that up here. And see if that makes a difference. Yep, there we go, I got it. There's my D. So that's the second character there. They're the character at index 2, D. So I've got all three of my exceptions handled somehow. And the null pointer exception actually goes back to the string. So actually I think this is a little bit confusing. So let me change it to do something with the string instead. And again, move it up. Not cake printing out in the event of a null pointer. Okay, but what if I made yet another exception? Boy, this is going to be hard to do. That is none of these. What if I made another exception that was none of these? Let's say I tried to do this. C equals C plus integer dot max value. So of course, integer dot max value is bigger than, well, the maximum value that an integer can be. And I'm going to do this before that, so I don't have the out of bounds exception instead. Let's see what exception I get there. It's out of bounds, out of bounds, out of bounds, not cake, 2. So I'm getting 2. And I'm getting 2 because this little guy right here still falls under arithmetic exception, so that's fine. So I can still actually handle that one. Let's try something else. What other errors, or what other exceptions can I come up with that I haven't handled here? So besides these 3. And you can let me know in either chat if you can think of any. What other exceptions are there besides the 3 that I've attempted to handle as already? What other exceptions can I trigger? What other exceptions have we seen? You've seen divide by 0. You can do overflow with adding max integer, but those are both covered by arithmetic. We've got our out of bounds exception. What if we try to access a index that is negative? What if we try to say big equals chars of -1? Is that going to be a different one? It's out of bounds. Still, so also covered by out of bounds. Oops. Anything else that we haven't covered yet? Any others that we've run into? I'm sure you've run into so many exceptions. And yes, now it's just hard to think of any. Alright, well, for this, let's check out our lovely Oracle documentation for the exception class and look at their documentation, which tells you all of the known subclasses. So we should see a couple familiar ones in there, maybe. Let's see. Da, 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 da. Well, nothing that we've used. Maybe IO exception for reading from the keyboard and such, if we've done that in the past, but we haven't done that much in this class because we read from the keyboard using the swing functions directly. So not an awful lot in there for us. But let's say that you did want to capture all of the other available exceptions that there were. In that case, you could add the default catch-all exception, E on the end. And in this case, we would print that it's something else and do the stack trace accordingly. Okay, and you can name all of them E again. Local variables don't count outside of that block. So if you want to name all your exceptions E by convention, that's not an uncommon thing to do. Alright, I think that covers it for exceptions. There are also other ways of dealing with exceptions, namely throwing exceptions, but we're not going to get into that in this class. You will probably get into it in 328/229, and if you want to look into it a bit, that's throwing exceptions again, so throwable, that sort of thing. Alright, let's move on to our next thing, which is going to be array lists. And before we move on to that, I will sync us up with the remote. So here we go, add those things, finish the exemption example, started array lists. Lovely. Okay, so for the array list example, I'm going to make a couple of objects so that we can have lists of something more interesting than just ints and stuff. So I'm going to make a class called record, and this is just going to be some piece of data that we store. So let's say we have string name and int salary. Those are going to be all we have in our record, and then we'll make a constructor for those things. And I'll also make a shorthand constructor for keeping the salary at 0, because I didn't get to do it in the last example. There we go, seeing that salary has no default value, we'll see if that works. And let's do our record manager. Record manager is going to have a list of records. So first let's try to do it the regular way. Let's try to do it with arrays records. Oops. Alright. Let's say that we want our record manager to support any number of records so that we can keep adding them as we go. So let's say that we want to be able to support 25 or 50 or whatever. What's our approach right now if we want to do that? How would we specify the size of our records array here if we want it to be able to support 25 or 50 or 100 records down the road? What can we do here? Should I just say 25? Let's say that I anticipate that the max is going to be 100, but I'm not even sure if it goes over 100 too at some point. What can I do? 25, should I say 30? And specify the amount in the constructor, and that lets you tell me how many records you want when you construct it. So when you first instantiate your record manager, that might be a good idea. Int num records. But that still isn't a complete solution, because what if I don't know at that point either? So what if my record managers are always in this situation where perhaps I want 25, or perhaps I want 50, or perhaps I want 100, and perhaps I want even more? So if I go back to my driver and I make one, what should I give it for how many records it should have? Same question. Let's kick the can down the road a bit. What should I specify in the constructor if I'm dealing with a use case where I want maybe 25, maybe 50, maybe 100, maybe more? The only thing I really can do, at least simply, is to make it what? What's the simplest solution I have for? I have a bunch of stuff. I'm not sure how much stuff. Well, the simple solution is to make it way bigger than I think it needs to be, right? That's the easiest way to do it. So if I think I might need 50 or 100, but I think I might want more, well, I could make it much bigger. I could make it like 500, or I could make it like 200 if I think I'm never going to go over that. And hopefully I stay within those limits, right? But of course we realize that this is a pretty big waste of resources, because we're creating an array that's much larger than we need. We're using up a lot of memory when we don't have to. And there is still the chance that it will end up becoming full, right? There's still the chance that it will end up becoming full. So let's try using a less useful number. Let's try making it 10 big and seeing what happens when it gets full. Okay, so in order to support this kind of mechanism, let's say that I want to be able to insert records and then remove records by name. So I think we've seen how to do this before, but let's review it again, because it's a little bit complicated when you're dealing with a list like this that's not in any particular order. So these records are not sorted at this time. So let's go with public void insert record. It's going to take a record R as an argument, not insert rector. I don't know what a rector is. I just forgot how to spell record. Insert record. So what do we have to do? We have to loop through. We have to find the first available spot. I is less than records dot length. How do we find the first available spot? What are we looking for? Are we looking for if records of I is what? And we're searching for to indicate that it is empty and available for insertion. You're looking for a null. And then we're going to set it, and then what else did we have to do? The important pitfall that you have to remember. What do we have to do beyond this? The records of I equals R, and then what else? And there's something else that needs to happen right there, otherwise we're going to encounter some problems. When we try to insert records, we're going to end up having a bunch of duplicates across the whole array. Remember, if we don't have that extra line when we're trying to find the next available empty spot, we set the next available empty spot to the record we're trying to insert, and then what do we need to do after that? We need to either break or return. I think I did return last time, so I'll do break here. Break, of course, escapes the for loop, which brings us to the end of the method here, or we could return immediately if that was more appropriate. In this case, those are the same. And just to demonstrate an example where perhaps break is more appropriate than return, let's say that after you inserted it into the thing, we just wanted to print out something like, I don't know, inserted a record. Sure. This would only be possible if we braked. So if we wanted this to happen every time then break would be more appropriate. On the other hand, what if you wanted to do something like this? You wanted to say, like, failed to insert a record, array is full, failed to insert record, array is full. Well, in this case, when we break, it's still going to execute that line. It's going to leave the for loop and still execute it. But if we were to return instead, and then we did our opposite print here, our inserted record, and maybe I want to print them out. So let's go and print r.name at I. Now I have a system where I am doing this if the insertion is successful, and if we've gone through the whole array and there aren't any that are null, it will print this statement by default at the end. So in this case, return is more appropriate. So it depends on your case. If you have stuff that needs to happen after the loop, then probably break is more appropriate. If you just want to exit immediately, and then the stuff at the end of the loop is what happens in the event that a spot is not found, then return is more appropriate. Next, let's look at remove record. We're going to remove our records by name. So we're going to find the record with the matching name and remove it. So again, there's going to be a for loop, and we're going to perform a null check. Let's perform the null check a little bit differently, though, because we already gave it a shot in the previous example just now. Let's do it with exception handling. So I'm going to do what I'm going to do, and I'm just going to do it all inside of a try catch block. Alright, what do I need to do in order to remove a record by name? So I'm looping through the records, and what do I want to do for each one that I find in order to see if it has a matching name? So I'm going to see if what records have I. How do I see if the names match? Or how do I check if the names match? Think carefully, because it's a bit of a trick question. Okay, so you fell for my bamboozle, which is to say that there's a slightly different thing that you have to do when you're comparing strings, right? So you were correct in that Discord answer that it's if records of I equals name. However, remember that we can't, or that we shouldn't compare strings with double equals. And we should know to an extent why by now. Can anyone say in either chat why you can't compare strings with double equals now that you know a little bit more about objects than you did at the beginning? Why can't you compare strings with double equals? It's the same reason that if you had two doodads, if you had like doodad A and doodad B, and they both happen to have some kind of property that identified them, for example, a name. In fact, in this case, we could easily say record A and record B. Okay, you know that you wouldn't be able to check if A equals B. You know that's not really something that you can do. How come that's not something that you can do? How come this double equals isn't something that you can do, and how come the same is true of string? How come we can't compare strings with double equals? This doesn't make sense for the same reason that comparing strings with double equals makes sense. Let's get some more liveliness in the Discord. With only one person answering, it takes a long time to get through these questions. Adding a lot of class time on the end of it today. No wrong answer, too, obviously. So feel free to give it a shot. How come? How come that double equals comparison doesn't work for records and it doesn't work for strings as well? And it is a valid line in the sense that it does actually like compile and run and everything. And there is a use for double equals when comparing objects. It's just not the use that we're usually thinking about. So the answer in Discord is that equals compares object references and equal equals checks value. That but flipped, the double equals compares the object references. So it actually checks, if you execute this statement, if A and B are the same object. So this would only evaluate to true if you were in a condition like this. If A and B were literally the same object, then this would be correct. But generally speaking, when we're comparing objects, we care something about their value. So maybe we're comparing two records because we want to see if both of the records have a value of 4. In that case, we are checking if the salaries are equal. That's really what we're interested in. And it's the same way for our string comparison. We really don't care if these strings are identical. What we're looking for is whether or not these strings have the same value internally. Now the reason, unfortunately, that this doesn't work for all the other objects in Java, but it does occasionally work for strings. So for example, if you did string cake and string cake like this, I showed you actually that this worked at the beginning of the semester or something like this. And I told you that the fact that it works is really the dangerous foot gun because it works only occasionally. And the reason that it works is that anytime you specify a string literal, so something inside of quotes like this, Java has a little bit of an optimization where it will save all of these in a common place, and it will treat all of them like the same object, even if you didn't explicitly tell them to be. So it will actually think of those two as this, which is an unusual thing for it to do. But as soon as one of them deviates, so if you did something like A plus equals 3 and B plus equals 3, as soon as they deviated in terms of their value, then the references would no longer be the same, and then the double equal wouldn't work anymore, even though they're identical. So it's a really weird optimization trick that Java does. It saves a lot of resources. It's a good optimization trick, but it leads to the double equals occasionally working for string comparison. And all that to say, if you don't care about any of that, don't compare strings with double equals, and don't compare objects with double equals unless you're trying to check if they're literally the same object. So if you care more about their value or something, do that. And keep in mind that you can always write your own equals method. You'll see lots of things in the Java library have a dot equals because they want to be able to do these kinds of comparisons. So it's not an uncommon thing to write one for your own objects to designate what it means when two objects are identical in terms of their values, but they're not exactly the same object. Alright, so if records name is equal to the name that we're looking for, we are going to remove it, which just sets the spot to null. Do we want to remove all the occurrences or just the first one that we find? If we want to remove all the occurrences, then this is fine. It'll loop through every record and return every record that matches the criteria. If we want to return just the first one, then we're just going to return after that, and then we won't look at the rest. So this will remove the first one from the front. And if we wanted to remove the first one from the back, then we would just have to flip the for loop around. Alright, so I will comment that this removes the first one, removes the first record from the start with a matching name, and then perhaps we might have a remove all records, where the only difference is that we don't have that return statement, so it continues to look through all of them and just removes all records with a matching name. Okay, that gives me pretty much everything I need to insert and remove records and handle them. Let's write one more method just to do something with the records. I'll copy my for loop here in order to do it. I'll do a sum of all the salaries. Get sum of salaries. And that'll loop through. I'll have an int sum that starts at 0. We'll loop through for all the null records. We're going to add the salary to that sum. And then we'll return the salary at the end. So nothing too special there. Return the sum at the end. Nothing too special there. We're just summing up all the not null records that we happen to have. What did I do? Oh, forgot to make it an int. Returns the sum of the salary of all records. So this was kind of hard to do, and there's certainly a lot of baggage involved, and it still runs into the issue that if we were to insert more than 10 records, so let's try to insert some, so manager dot insert record, I'll do a new one, let's go with A, here's a salary of 50, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that's too much. Let me just make it 5 big. Alright, I've inserted 6. So A, B, C, D, E, F. Some random salaries. And we'll do, actually, let's just make them all 50 so that we can do the sums easier. That's probably for the best. And then we'll print out the sum at the end. Get sum of salaries. Okay, so if we ran this, we get the fail to insert a record issue over there because, of course, we're out of indexes once we get to 4. We only have 5 spots in our record manager. And then we get the sum of the salaries. It's giving me 0 right now. What did I do that? What did I do for that? That seems to work. Whoops. I said equals equals null. I don't want to do that. I want the opposite there. I want if it's not equal to null. So now I should get 250. Okay. And let's see what happens if I only have a few records in there. So let's say I only have 3. If I only have 3 records in there, then what should the sum be? Well, it should be 150. Let's look at what happens if I use that default no salary constructor in records. So this one that doesn't specify the salary, the one right here, it doesn't do anything with the salary. So does that person have a salary of 0? Yes, they do. It's 100 instead of 150. So you give them that designation of 50, you get 150, you omit it, salary defaults to 0, and you end up with 100. So interesting quirk there that you get the default value in that circumstance. That's what I relied on for that water pump example again. Alright, let's try to remove a couple. So let's go with remove record. We're going to remove one with the name A. And then we're going to get the sum of the salaries again. So that should give us 200 because we've gotten rid of 1. And let's try to remove C, and then print the salaries again. Let's insert a new one. New record D. Salary of 50. So I've copied D in. Now we have 2 instances of D. The sum of the salaries should be the same here. Let's see if I can remove all of them with manager dot remove all records with name D, and then get the sum of the salaries. What should it be here? So it was 200. Then I added C, or sorry, it was 200, then I removed C and added D, so it's still 200 then. And then I removed all the occurrences of D. So what should be after that? Well, I should have two occurrences of D. I should have this one and the one that I just made. So I should see 100 at the end here if I got rid of all of them. There we go, I do see 100. Okay, so all of that was great, but it's definitely not convenient, and it's an awful lot of code. So now let's take all of that and think about how we can replace it, and I'm going to do so by creating an ArrayList. So record manager ArrayList version. Have a longer name and everything. So today we're just going to look at a couple of the basic operations because we don't have a ton of time. Next time we're going to wrap up ArrayLists, and then the rest of the semester we're just going to be going through relatively complex examples, just applying everything that we've learned together. Alright, so first the syntax for ArrayLists, which is incredibly painful and uses symbols that you've probably never seen before. So an ArrayList is actually an object, like string is, for example. It doesn't have the same syntax as an array. The first thing that you need to specify is what kind of object you're storing in the list or in the array. So let me take this array designation as a reference. Here we specified that we needed records, and we did it by specifying the object type. But if the object type is already ArrayList, well, how do you specify the kind of objects that you want inside of it? You can't say like ArrayList record. An object can't have two types. So what Java came up with for this situation, where you already have an object, but then you want to specify what kind of objects it works with, or what kind of objects it contains, is this caret symbol. Okay, so the caret symbol, or the stuff inside of the carets, tells you what kind of object is stored in this array list. So this is an array list of records. Now on the right-hand side, we're generally going to do this in the fields or in the constructor. On the right-hand side, we have to do the whole new thing in order to get the object instantiated, and we do the same thing with the carets over there to specify that we want an array list of records. And since we're using that new keyword, we still have to invoke ArrayList's constructor, so it's easy to forget that you also need to do parentheses at that point. And I need to import my array list. Notice I get a different color for the stuff inside of the carets too. So you need these parentheses because if it was a regular object, like for example a record A equals new record, well of course you would have parentheses, right, and stuff inside of them for the constructor. That's what the parentheses are here as well. And you can actually specify a number in here, and the number we'll talk about later is the default size of the underlying array. So it does take an argument, but we don't need to give it one. That doesn't matter. The default constructor is fine here. Alright, so that's how we specify an array list. Any questions on that so far, on these little brackety doodads and what they do? Is there any shorthand that we can achieve to do a little bit less? Yes, but all of the different shorthands will have Java yelling at you a little bit. We can infer generic arguments and do some stuff there, change it, and just go back to what we had in the first place. There are other shorthands for ArrayList designation, but I'm pretty much always going to use this one when I'm dealing with them in this class because this is the most clear, to me anyway. It very specifically addresses what it is that you are trying to do. Alright. What is an array list? So our public record manager array list doesn't have to do anything anymore because we don't have to set up the size of the array list. Let's say that we want to insert a record like we did in the previous one. In fact, I'm going to copy it so that I have the same names for certain. So I want to insert a record. In order to insert a record into an array list, all you have to do is say records.add and then the record that you want to insert into the array list. And it's done. And so what an array list is very similar to an array. It's a data structure that holds a bunch of things. But unlike an array, you don't have to specify its size. an array list can grow indefinitely. So it solves that problem that I was talking about at the beginning, the what if I have 25 records, what if I have 50, what if I have 100, what if I don't know how many that I'm going to have? An array list doesn't care. And it accomplishes this under the hood by being an array, but it does a little bit of an interesting thing. Instead of just saying failed to insert array is full when it's too big, what an array list does is when the underlying array that they've got there fills up, it makes a copy of it and makes it 1.5 times bigger. Okay, so you can think of an array list as managing that array for you under the hood. It performs all of these functions and more, and it does a much more complicated thing than this. Rather than failing when it's full, when an array list gets full and you try to add something, it will copy what it already has and make a new array that's 1.5 times bigger and then continue on from there. So let's say that our records filled up here. We had 5 as our starting size. Instead of saying that it would full, it would create a new records. So it would be like records equals new records of, and then whatever the size of records was, records.length times 1.5, and it would round that to the nearest integer. 1.5 is the default value last time I looked it up. They may have changed it, that's a possibility too. But 1.5 is what it says in the Java documentation last I looked. And it seems like a fair compromise. And then after it did this, right, so really it can't do this, so it would have to do record new records. After it did this, it would then copy all of the contents in, which is going to be a bit of a process, right? So we have to do that for loop again. We don't care if things are null. We want to copy the null spots over too. So we're going to say that new records of I equals records of I. And then after we're done doing all of that, then the records array will become this new one, and we can continue on. So let's see if that works for our implementation of the record manager. I've got my failed to insert. This needs to change now to growing the array to a larger size. What happens there? And then I still haven't handled the problem of actually inserting the item that you wanted to insert. I guess as the last thing we do in class here. Well, there's not enough time for me to make you answer it. So the new position to insert the thing at will be the size of the old records array. So it would be new records of records.length plus 1. That's where we're going to put the new thing. Let's leave this as a to-do for next time so we can go over that in more detail. Alright, that's it for today, and I will see you next time to finish up with ArrayLists, but keep thinking about how this might work. Growing it larger dynamically when you add an object that's over works in practice. Okay, see you next time.